Hi, I'm Joe Feeks, editor of Pig Health Today, and with me is Noelle Noyes. She's a veterinarian and epidemiologist at the University of Minnesota. Thanks for joining us today.
Thank you.
Antibiotic resistance is a concern with veterinarians, I think, in all aspects of food animal production. I know the pork industry has a very good reputation and track record for managing antibiotics responsibly. But how do we know that we're winning this war against antibiotic resistance? Are there tools available?
That's a really great question. I think that it very quickly becomes very complex. When you're trying to look at a specific management factor, whether that be antimicrobial use or other things that we're doing in livestock production, and trying to understand how those practices either mitigate or promote resistance, it's just a really difficult question to tackle. And we've had tools for a long time that we've been using somewhat successfully to understand some specific aspects of that relationship. But more recently, I think because we have some new technologies, we're able to really get a more comprehensive picture of how what we do in livestock production may either help or hurt the antimicrobial resistance fight. And so with those tools and technologies, I'm very excited because I think that it will allow us to have a much deeper understanding of what we're doing, and that really helps us provide better and more robust evidence for what we need to change or maybe what we're already doing really well.
Now, I know in the past there's a test called MIC, minimum inhibitory concentration.
Yes.
Is that still a tool that is being used for measuring the resistance to an antibiotic?
Yes, that's a very commonly used tool. It's been around a long time, and the nice thing about that tool is that we just have all of this historical data to help us understand, well, what does it mean when I see a particular MIC value? And so really the benefit of that test is that we're pretty easily able to interpret what it means. Some of the new tools and technologies, they're less well known. And so when we get a result from those, it's very difficult for us to have any context about what that value means, what it might mean for human health or animal health, and really how risky that value is.
Now, why do we need the new tools in the first place?
I'll give a little bit of background, I guess, on the MIC values. So the MIC value that you mentioned really comes from a culture-based approach to looking at resistance. And when we culture for things, we have to sort of pick our organism. So we have to pick either Salmonella or E. coli or maybe an animal pathogen. And we have to just specifically grow that pathogen and determine whether it can fight off or whether it succumbs to an antibiotic exposure to a drug. And so in that case, we have to focus on one organism. But now, because of these new technologies, we know that our world and ourselves are inhabited by millions of different bacteria. Most of them, we don't even know what they are yet. And all of them can have resistance. And so when we're looking at just one little bacteria amongst all those thousands of different types of bacteria, we probably aren't getting a very representative picture of the resistance dynamics across the whole population. So it would be like just going into a small town in Minnesota and surveying those people. It's not super representative of what's going on in around the entire globe, right? And so these new technologies, I think that they're needed because we need to understand, in order to truly fight resistance, we really need to understand what the entire microbial population is doing, not just the bugs that we're interested in.
So tell me specifically, what kind of technology is this? How does it work? How do veterinarians access it?
Yes, so it's happily it's becoming more accessible, but it's basically sequencing technology. So you've probably heard that you can sequence your own genome. You can probably sequence your dog's genome, and we can sequence all the bacteria in a sample now. So these machines are so powerful, and they can give us so much data that we can take a sample, and instead of focusing on specific organisms, we just take all of the DNA and we sequence it. And then we can look at that DNA and we can compare it to sequences that we know exist already. And if we find a match, we can say, okay, this is bacteria X. X, and this is resistance gene A. And so using that technology, we're able to get a picture of the entire population. And that includes even, if I make a mistake in the lab and I get some of my human skin in there, I sequence my own genome along with all the bacteria. So we get everything that's in there.
So before, we'd be targeting a specific organism, Salmonella, Mycoplasma, for example, but now you get everything that is circulating in that animal.
We do. I mean, we have to understand how deep the sequencing is. So do we have enough sequence that we're capturing all the really rare bacteria that might be in the population? So those are questions that we don't fully understand yet, but we are having a snapshot of the entire population in that animal.
So you get the snapshot of the population, but what does that tell you about resistance?
So what we can do is not only look at what bacteria are there, but we can actually look at what resistance genes are there. So now, instead of looking at salmonella and saying this specific salmonella has these 3 resistance genes, what we typically find now is that when we look at all of the DNA, we're finding hundreds or sometimes even thousands of different resistance genes in one single sample. And that's really interesting because it sort of shows us that resistance is a natural phenomenon. We don't really think about that, but bacteria are naturally resistant to different compounds. It's a way that they've evolved to survive in the face of different challenges. And so when we, for instance, even go to pristine environments or up into the Arctic and we take samples, we will find resistance genes in those bacteria despite the fact that they've never been exposed to sort of modern day antibiotics. And so that, I think, is one of the really interesting things about this technology is that it gives us this more comprehensive picture about resistance and the fact that it's a natural phenomenon, and what are we as humans doing to shift that resistance profile.
Now, the new FDA guidelines that came along in 2017 require veterinarians to be involved in the use of any medically important antibiotics. And as I said before, I think the pork industry, and particularly veterinarians, have a good track record for managing antibiotics responsibly and judiciously. Yet, from what you're telling me here, there are still some resistance problems or potential problems that could emerge.
Yeah, I think that whenever we're managing populations of things, be it people or animals or even the environment, we're doing things to the microbial population. We don't really think about it because they're microscopic and we can't see them, but we're shifting their ecology. And so, this is where I think that it's not just about antimicrobial use. To me, it's about the whole system of livestock production and what are we doing already that potentially is helping actually in the antimicrobial resistance fight, and what are some of the practices that we need to sort of rethink. And so in my mind, I would like to, when I design a study, I like to think not just about, okay, this is how we're using drugs, but this is the other things that we're doing within that system of livestock production.
Now, I think we're all pretty aware of the types of practices that could promote resistance, half dosing or not feeding something for the full duration, for example. What are some other factors that could make antibiotic resistance more of an issue?
Yeah, well, so one thing I will say about your question, there are some really interesting studies coming out in human medicine where actually short-term dosing is actually showing to be just as effective in decreasing disease, but also potentially more beneficial in terms of keeping resistance sort of dampened down. So some of those duration questions, how long should we take a drug? This is a big deal right now in veterinary medicine with label durations for some drugs. I think that we don't really have enough evidence to understand how duration affects antimicrobial resistance. And that's something I'm really interested in looking at because I think that one thing the veterinary community's been really good at doing, like you said, is trying to get a handle on stewardship. But maybe something we could do a better job on is creating some evidence around our stewardship. So can we provide evidence that what we're doing really is making a difference, right? And so I think getting a handle on how the way we use drugs and the duration with which we use drugs helps with disease and with resistance, I think is really important to build that evidence base and to really prove that, the practices that we're trying to implement are having an effect.
Have there been any big surprises in your work?
Big surprises.
in terms of antibiotic resistance?
The reason I'm having trouble answering is because I feel like every day there's another surprise. But yeah, I think one of the biggest surprises to me, you know, coming in as a student, you have this idea of antibiotic resistance as this sort of very linear phenomenon, right? Where you give a drug, you get resistance. And I think one of the biggest surprises to me when I started getting started in this was just how complicated the issue is, and just how hard it is to really predict when antimicrobial resistance is going to become an issue.
And what are your thoughts about using antibiotics to prevent diseases? Because there are some people that will say, well, the pork industry shouldn't be using an antibiotic to prevent a disease, even though there's ample evidence that the herd might be vulnerable to that disease. What are your thoughts on that?
Yeah, I think it's a really tough issue, and this gets back to what I said about I think that we need to start building some evidence that those practices really do increase animal health and welfare, and the alternative may be harmful both from animal welfare perspective but also from a resistance perspective. So I think that if we can get a handle on sort of the cost benefit of giving a preventive dose of antibiotic and what that means for animal health and welfare and what it means for resistance, I think we can have a more evidence-based discussion about the benefits and drawbacks of those types of uses. Yeah.
So getting back to the technology that we discussed before, where is this available? Is this something that the University of Minnesota is offering now?
Yeah, so pretty much any university would have this technology, and of course private companies also have this technology. I think having the technology and generating the data is not the hard part anymore. The hard part is analyzing the data and interpreting the data. So that's right now, in my mind, where the bottleneck probably is. And then also understanding our sensitivity for those measurements.
Well, Noelle, we're going to have to keep a close eye on this, and I have a feeling we'll be discussing this again at another conference.
Okay, thanks so much.
We've been talking to Noelle Noyes. She's assistant professor at the University of Minnesota. Noelle, again, thanks for joining us.
Thank you.